All right, we're going to go ahead and today. I'm still having an issue with the grades in Hawks not being sent over to D2L. So if you notice that some of your grades are missing in D2L, you're not alone. It's happening to several people. I have a case opened with D2L, and they're trying to figure out what the issue is. I've tried to manually import everyone's grades one by one, but it takes about 5 minutes per person. So 5 minutes times 200 people equals too much time for me to sit here and click all those buttons. So we're going to see if D2L can figure out what the issue is. But in the meantime, just know that some of your grades in the homework section may not be showing up in D2L, but we'll get it fixed soon. All right, so today we're going to be talking about 7.2, but before we get started, let me just remind you that we do have a quiz due tomorrow night. That quiz covers Chapter 6, which is just sections 6.1 to 6.4. I told you guys yesterday the grades so far have been pretty good on this quiz, so I have total confidence that this will be one of those quiz grades that really helps boost your average up. And don't forget, the homeworks for Chapter 6 are also due tomorrow, as well as the practice quiz, number 4. All right. Oh, and someone emailed me yesterday and told me that there was a due date that was wrong in Hawk, so I fixed that this morning. So the 7.1 assignments they had the wrong due date on them, so I fixed that this morning. Okay, I'm going to switch over the camera and we're going to go ahead and get started. All right, so section 7.2 is called Central Limit Theorem Means. Now what we're going to be doing in this section is we're going to take what we learned yesterday, which was, if you remember, we learned that the central limit theorem tells us that as long as we have a sample size that is greater than or equal to 30, we can assume that the sampling distribution of sample means is approximately normal. And remember what normal means. Normal means it's bell-shaped and symmetric. All right, so as long as our sample size is greater than or equal to 30, let me see if I can get that little tail out there longer. That looks a little bit better. As long as your sample size is greater than or equal to 30, we can assume that the sampling distribution of sample means is approximately normal. And we also learned a couple of little formulas. We learned that the mean of a sampling distribution of sample means, which is denoted by mu sub x bar, is just equal to the mean of the population. And the standard deviation of the sampling distribution of sample means is equal to this standard deviation of the population divided by the square root of n. And remember, we said that this part down here, dividing by the square root of n, that's really rewarding you for having a large sample size, or it's going to penalize you for having a small sample size. So it's either going to make your population standard deviation be smaller. That's if you have a really big sample size, like 1,000 or 500. Or if you have a small sample size, it could make your standard deviation inflate. All right, so we're going to use these two facts today. And some of the keywords that you're going to look for, you could probably guess. Some of the keywords you're going to be looking for in the problem is this word sample. All right, so you always want to keep an eye out for this word sample. So whenever you see something about a sample mean, then you know that, okay, I'm going to have to use these little formulas here. All right, so if you see the word sample mean, just know that you're going to have to use these formulas. Okay, so the first or the next formula, I should say, that we have is the standard score for a sample mean. This is really simple, and the only part you need to know is just this N part right here. I'm going to rewrite it. And this says that if your sample size N is at least 30, or if the population is normally distributed, then the standard score for a sample mean in a sampling distribution is given by, this is the standard score formula. It goes X bar minus the mean divided by population standard deviation divided by square root of N. All right, so you'll notice our normal standard score formula is just X minus mu over the standard deviation. So you can see that that standard deviation has been replaced by our formula for the standard deviation of a sampling distribution of sample means. All right, so this is the important part right here. If you're writing this down on your own paper, this is the part you want to write down. And it just says down here that X bar is the given sample mean. That means it's going to be given to you. Mu is the population mean. Sigma is the population standard deviation. And N is the sample size used to create the sampling distribution. All right, and then I also wanted to point out just this part right here. It says your sample size needs to be at least 30, or the population is normally distributed. So that's something you want to look out for in the problems. You want to think, okay, do I have a sample size of at least 30? If you don't, you also want to check in the problem and see, does it say anywhere in here that I can assume that the population is normally distributed? All right, so just keep an eye out for those two things as we go through the problems. All right, let's see. Oh no, where did my little writing go? Did I? Well, that's aggravating. Okay, I think I can remember what these were. I can just look at the PDF that I put up earlier. All right, so it says calculate the standard score, the z-score, of the given sample mean. Round your answer to 2 decimal places. Now, let me pull up, for some reason I remember earlier something happened in it, said some of my data was lost, but I couldn't figure out where it was at, so that must have been where it was. So this said mu equals 17, sigma is 6, mu equals 17, sigma is 6. All right, and then N is 78, X bar is 16. Okay. And it just wants us to calculate the standard score, also called the z-score, of the given sample mean. So we're going to use this formula right here. It's a pretty easy formula, so I'm going to slide it off the screen. I'm going to write down the formula. Z equals X bar minus mu divided by population standard deviation divided by square root of N. Here our sample size is bigger than 30, so that means we are allowed to do this. All right, so X bar is 16. 16 minus mu is 17 divided by sigma is 6. Square root of N, so that's square root of 78. All right, let me just make sure. Yep, just making sure all my numbers were correct. All right, here's my calculator. Let me see if I can scoot it over a little bit. There's my little boy right there. All right. Now let's plug this in. I'm going to do this just like in 2 steps. So 16, I'm going to do the numerator first. 16 minus 17 is, of course, -1. All right, so then I'm going to do -1. Well, let me erase this part here. I don't need to write that. All right, so now I have -1. And then I'm just going to hit divided by. So it says answer divided by. Then I'm going to put the denominator in parentheses. 6, just so the calculator knows everything that I'm putting down here is in the denominator. So 6 divided by the square root of 78. And I'm going to get out of there. use my little arrow button to arrow out of the square root, and then close the parentheses. And there's our standard score. It says to round to 2 decimal places, so that is 1.47. Oh, excuse me, negative 1.47. Remember, it's important to keep the sign in there. You don't want to lose that sign, because the sign tells you whether the value is above or below the mean. So since this was negative, it tells you that your sample mean X bar was below the population mean, or less than the population mean. All right. Okay, so there's only one of these on the homework. This is probably not something you would see on the quiz. I would be more likely to put one of the next couple of problems that we're going to see is probably what I would pull from this section to put on the quiz. All right, so let me scoot down a little bit. Now, the rest of the problems that we're going to look at today are all going to be stuff that we've done before. So it should be somewhat review. And we're just going to incorporate new formulas that we know for the mean of a sampling distribution of sample means, and for the standard deviation of a sampling distribution of sample means. All right, so same thing we've done before. We're just incorporating those two new formulas. All right, so let's look at this problem. It says, and it should sound familiar, the mean points obtained in an aptitude examination is 179 points with a variance of 225. What is the probability? All right, so probability, we know the answer is going to be a number between 0 and 1. What is the probability that the mean of the sample would differ from the population mean by less than 2.5 points if 77 exams are sampled? I'm going to change this a little bit. I'm going to add a little part 2 in here, and then we're going to do the part 2 first. Let me add in another part here, because this one is a little bit hard. Scare you with the first problem being hard. What is the probability that the mean of the sample is greater than 95 points? Round your answer to 4 decimal places. Okay, so we're going to start by doing this bottom question, and then we'll move back up and do this one at the top, which is a little bit more difficult. All right, so just to remind you, the mean they told us is 179. All right, so I'm going to write that down off to the side. Mean is 179. The variance, remember variance, the symbol for variance is sigma squared, is 225. What is the probability that the mean of the sample is greater than 195 points? All right, so we're going to say, what's the probability that the mean is greater than 195 points? All right, now let's think about this. Oh, I forgot to add one part in here. I should have said if 77 exams are sampled. Shoot. Sorry. You have to know the sample size for all these problems. All right. Let me start over. What is the probability that the mean of the sample is greater than 195 points if 77 exams are sampled? All right, so we've seen this keyword here, sampled, and we see it here also, sample. Those keywords, that keyword of sample tells us that we're going to have to use those special formulas for the mean and the standard deviation of a sampling distribution of sample means. We've already got our mean here, so let's just write our mean of our sampling distribution of sample means is just 179. The mean doesn't change. Now the standard deviation of the sampling distribution of sample means is equal to the standard deviation of the population divided by the square root of n. we're given the variance, so we have to figure out what the standard deviation is. Remember, if you want to figure out the standard deviation, you just take the square root of the variance. So square root of 225 is 15. All right, so the standard deviation is 15. So that tells us that our standard deviation of our sampling distribution of sample means would be 15 divided by the square root of our sample size, which was 77. Let's see, 15 divided by, actually, you know what? I'm going to leave it just like that. I'm going to leave it like that so that I don't have any rounding mistakes. All right. Now, since my sample size is bigger than 30, I know that this problem can be approximated by normal distribution. So I'm going to draw my little normal curve. All right, here's my normal curve. Put the mean in the middle. Mean is, let's see, 179. All right, and then we're marking our number that we're interested in, which is 195. And we're looking for the probability that the mean is greater than that. So we're going to shade to the right. Now this should feel familiar. This is what we did in chapter 6. The only difference is that we had this little bit of extra work we had to do right here. All right, but how do we calculate the area or the area under the curve or the probability when we're working with a normal distribution? You remember we just used that normal CDF function in our calculator. All right, so we're going to do, I guess I'll just use red. Normal CDF. Remember, it goes lower limit, upper limit, mean, standard deviation. All right, so lower limit would be 195. It's the lower limit of the shaded area. Upper limit of the shaded area is going all the way out here to positive infinity. So that would be really big positive number, like 10 to the 99. The mean we said is 179. Standard deviation, I'm just going to put 15 over the square root of 77. You can enter it in just like that. All right, so go to second VARS. Go to normal CDF. Now we're going to type in our lower limit and our upper limit. So 195, 10 raised to the 99. The mean was 179. Standard deviation was 15 divided by the square root of 77. Right, then we're going to paste it in. So if you typed it in manually, it should look something like that. And press enter. Oh my goodness. Of course, since I made this up, it's a terrible answer. All right, so we remember what this means, right? Remember when you have this little E show up at the end, that means you're going to move the decimal either to the left or to the right. This number is negative, so that means we're going to move it to the left. It says to move this decimal to the left 21 spots. So if you move this decimal to the left 21 times, that number is approximately 0. Oh, it's a terrible answer. All right, so that one had a terrible answer because if you remember, I made that up right before we were about to do this problem up here. So that's why the answer was not very good. All right, let's go back up here and do this first one. Now that we just remember how to do this, we remember how to go to second VARS, we do the normal CDF, all that stuff. So this one says, what is the probability? I circled probability there just to remind you. The word probability tells us that it's going to be a number between 0 and 1. What is the probability that the mean of the sample would differ from the population mean by less than 2.5 points if 77 exams are sampled. All right, so I'm going to draw the picture. It's going to be a little bit easier to see what the question is asking once we draw the picture. Put the mean in the middle. Mean is 179. All right, so it says, what's the probability that the mean of the sample would differ from the population mean by less than 2.5 points? All right, so let's figure out what would be to the left if we went down 2.5 points. So 179 minus 2.5. That would be 176.5. All right, so mark that on the left, 176.5. And then let's see what if we went up 2.5 points. Is 181.5. Okay, so go ahead and draw your line straight up at your two numbers that you're interested in. All right, so it says, what is the probability that the mean of the sample would differ from the population mean by less than 2.5 points? So that's saying, what's the probability that a person scores, or excuse me, that the mean of the sample is somewhere between 176.5, because that's 2.5 points less than the mean, or up to 181.5, because that's 2.5 points greater than the mean. So if you see these words differ by less than, that means find those two numbers, shade in the middle. So if you see differ by less than, that means shade in the middle. We're going to see in a minute, we're going to see a problem that says differ by more than. And on that problem, you'll have to shade on the outsides. So that'll be where you shade the tails. All right, so I'm going to write out what the probability notation looks like just in case you're interested. If you were writing this out using our probability notation, this is what it would look like. It would be probability that the mean is somewhere between 176.5 and 181.5. All right, and if we're typing this in the calculator, remember that's going to be normal CDF. Goes lower limit, upper limit, mean, standard deviation. All right, so lower limit. Lower limit of our shaded area is 176.5. Upper limit of our shaded area is 181.5. The mean is 179. Standard deviation is 15 over square root of 77. And again, you see that keyword in there, mean of the sample. All right, so seeing that keyword sample tells us that we're going to use our formulas for the sampling distribution of sample means. All right, so clearing everything out, go to second vars, normal CDF. Lower limit is 176.5. Upper limit is 181.5. 179 for the mean, 15 divided by square root is 77. So if you typed it in manually, it should look something like that. Make sure you have all your little commas in there. I know some people are using the Casio, but it should still look something like this. Lower limit, upper limit, mean, and standard deviation. And there's our answer, much nicer than the one I made up. 4 decimal places would be 8564. So that's about 85.64%. All right, so hopefully that looks familiar to what we did in Chapter 6. Still using normal CDF, that normal CDF function in our calculator. The only difference this time is if we see that keyword sample, we're going to remember to use the formulas for the sampling distribution of sample means. All right, here we have a two-part question. This one is a little bit tricky, which is why I wanted to cover it with you guys. And then at the very end, we're going to do one of those that I told you about before that says would differ from the population by more than. All right, so we're going to do, I just picked out the ones that I thought were the difficult problems from this section. All right, so it says intelligent quotient or IQ scores are often reported to be normally distributed with a mean of 100 and a standard deviation of 15. A random sample if 47 people is taken. All right, so our sample size is definitely big enough. It's definitely bigger than 30. Mean is 100, standard deviation is 15. All right, so read this question carefully. What is the probability of a random person on the street having an IQ score of less than 96? Notice how it doesn't say anything. It does not reference our sample at all in this question. You do not see the word sample. All right, so since you do not see those words sample in this part A, that means you're not going to use your formulas for the sampling distribution of sample means. You're just going to do part A just like we did in chapter 6. So do this just how we did in chapter 6. So we're not going to worry at all about our formulas for sampling distribution of sample mean. All right, so I'm going to go ahead and draw my picture. All right, so mean goes in the middle. Mean is 100. Mark your number of interest, which is 96. Draw a line straight up. And they were asking for the probability that someone on the street has an IQ score of less than 96. So less than, shade to the left. Think of this as a number line. These would be all of the scores that are less than 96. All right, so this would be the probability that someone's IQ is less than 96. So that's going to be, we can do this in the calculator using our normal CDF function. Goes lower limit, upper limit, mean, standard deviation. All right, so lower limit of our shaded area would be all the way out here at negative infinity. So that's negative 10 to the 99. Upper limit of our shaded area ends right here at 96. Mean, they told us was 100. Standard deviation, they told us was 15. Remember, we're not using our formulas here for sampling distribution of sample means. All right, so clear that out. Go to second vars, takes you to the distribution list. Go to normal CDF, lower limit, negative 10 to the 99, 96 for the upper limit, 115. So that's what it should look like if you typed it in manually. And then hit enter. And there we go. And that number looks totally reasonable, right? Like for the amount of the graph we have shaded in. So that's about 39.48% or so. Round into 4 decimal places, that would be 3949. 3949. Okay. Now let's look at part B. They call it like step 1 and step 2 in the homework. Now let's notice the difference in this wording. It says, what is the probability that the mean IQ score, you see that keyword in there, mean? What is the probability that the mean IQ score of people in the sample is less than 96? All right, so now we're having to take into account the fact that we're working with this sample of 47 people. All right, so we're going to draw our same little normal curve. Let me scoot this down a little bit. All right, so draw our normal curve. Mean in the middle. Mean is 100. Oh, that was a good normal curve. Probability that it was less than 96. So same as before. Draw a line straight up, shade to the left because that's less than. But this time, notice they inserted those keywords sample and mean. That tells us we need to use our formulas for the sampling distribution of a sample mean. So the mean of the sampling distribution of the sample mean is just the same as the mean of the population, which is 100. The standard deviation of the sampling distribution of sample means is equal to sigma over the square root of n. So standard deviation of the population divided by the sample size. So that was 15. And then remember they said we had 47 people in our sample. All right, so 15 divided by square root of 47. And just leave it like that. You don't need to get the decimal version of that number. All right, so we're going to say probability that the mean IQ is less than 96 is equal to normal CDF, lower limit, upper limit, mean, standard deviation. All right, so lower limit, again, is negative 10 to the 99 because it's way out here at negative infinity. Upper limit of the shaded area is 96. The mean is still 100. The standard deviation has changed. It's now 15 over the square root of 47. All right, so clear out your calculator. Second vars, go to normal CDF. All right, so negative 10 to the 99, that's right. Then 96, then 100, then 15 divided by the square root of 47. All right, then we're going to paste that in. That's what it should look like if you just typed it in. Then hit enter. And there we go. Much smaller, very, very small probability on that one. 0. If we round into 4 decimal places, that would be 0.338. Oops. 0.338. All right. Much smaller that time. And again, that is because you are being penalized, if you remember, for working inside of a sample. So your standard deviation gets affected. All right. We have 2 more questions. And these are 2 questions that I pulled off of the homework, and I kind of I made it a 2-part question. In the quiz, in the homework, it's actually 2 separate questions. It says Thompson & Thompson is a steel bolts manufacturing company. Okay, so they're manufacturing steel bolts. Their current steel bolts have a mean diameter of 148 millimeters. Okay, so let's write that down. The mean is 148 and the standard deviation of 7. All right, so that one's kind of nice because we don't have to worry about the variance like we did a couple problems ago. All right, and then it says if a random sample of 50 steel bolts is selected, okay, so sample size is 50. That was a terrible 5. Let me try that again. Here we go. If a random sample of 50 steel bolts is selected, what is the probability that the sample mean, okay, so we see that, the keyword sample mean, that tells us we're going to have to use our special formulas. What's the probability that the sample mean would be greater than 147.7 millimeters? Okay, so probability that the mean would be greater than 147.7. All right, so let's go over here to the side. Let's go ahead and calculate our special formulas for the mean of the sampling distribution of sample means and the standard deviation, the sampling distribution of sample means. The mean is just the same as the mean of the population, which is 148. The standard deviation, remember that's going to be equal to sigma over the square root of n, so 7 over square root of 50. We're just going to leave it just like that so we avoid any rounding mistakes. I'm going to go over here and draw my little picture. Oh, that was a pretty good one too. See if I can get that line straight. Mean goes in the middle. Mean is 148. All right, our number of interest, 147.7. Very close to 148. And then shade to the left. Oh, excuse me, to the right, because we're looking for the probability that's greater than 147.7. Now, if we were shading just to the left of 148, we would expect that to be exactly 50%, right? Because it's a normal curve. It should be symmetric. This is a little bit to the left of 148, so I'm going to suspect that this is going to be just a little bit more than 50%. All right, so that's going to be normal CDF. Lower limit, upper limit, mean, standard deviation. Right, lower limit is 147.7. Upper limit, positive infinity, so that's 10 to the 99. Mean is 148. Standard deviation is 7 over square root of 50. Okay. Clear that out. Go to second vars. I'm so tired today. I don't know why. 147.7 for our lower limit. Upper limit is 10 to the 99. Mean is 148. Standard deviation, whoops, press the wrong button. 7 divided by the square root of 50, close parentheses, and then paste. All right, so make sure that's what you have plugged in. And it is a little bit more than 50%. It's 61.91%. All right, so that's, for round to 4 decimal places, that would be 0.6191. All right, cool. And then our last one, I would say that to me, this is the next one we're about to do is the hardest one from this section. Any of those, I think there should be only 2 that you see on the homework, depending on if you get them right the first time or not. Oops, somebody chatted in there. Why would we not use the regular standard deviation of 7? That's a good question. So the reason that we don't use the regular standard deviation of 7 is because we see this key phrase in here where it says, what's the probability that the sample mean would be greater than 147.7? So when you see that word sample mean in the problem, that tells you to use your special formulas. Does that make sense, Rebecca? Okay, good. Whoa, why are you blinking like that? Okay. All right, and like I said, the hardest ones in this section are the ones that have that like differ by in the problem. But just remember, if it says differ by, you know that you're going to add and subtract that number from the mean. And then depending on if it says differ by less than or differ by more than, that'll tell you where to shade. All right, so it says, if a random sample of 50 steel bolts is selected, so same sample size as before, what is the probability that the sample mean, okay, so we see that key phrase in there, sample mean, that tells us to use our special formulas. What is the probability that the sample mean would differ from the population mean by more than 3 millimeters? All right, so I'm going to do just like we did before with that differ by problem. I'm going to start by drawing the picture. All right, so draw your picture. Put your mean in the middle. Mean was 148. We can see it right there. All right. And then it says, what's the probability that differs from the population mean, which is 148, by more than 3 millimeters? So go up 3 and go down 3. If we went up 3, that would be, what, 151? So just added 3 to that. If we go down 3, that would be 145. Just make sure. Yeah, okay. just checking. All right, go ahead and draw your line straight up at both of those values. Totally missed that one. Try again. All right, so it says, what's the probability that the sample mean would differ from the population mean by more than 3 millimeters? So that means, what's the probability that it's more than 151 or that it's less than 145? So shade in the tails. So shade the tails this time. So I'm going to write out how you know which way to shade. So if you see the key words here, differ by more than, that means shade in the tails. And remember the last problem we did a couple of problems ago, the last one we did that was a differ by problem. It said differ by less than. So if it says differ by less than, you shade in between. Right, now we did a problem like this back in chapter 6, and I told you guys that to me, what I think would be easier is to use the fact that we know that this entire area under the curve has to add to 1. So what that means is that we can just find this middle piece, subtract it from 1, and that'll tell us the pink area. So we're going to do 1 minus the yellow area is going to, I know somebody told me last time not to draw it in that color. Let me do it in black. 1 minus the yellow area is equal to the pink area. So we're going to find the yellow area because that's pretty easy to find. And that'll tell it, we'll do 1 minus that value, and that's going to tell us our answer. Now, if we were writing out this in probability notation, we would say the probability that the mean is less than 145 or the mean is greater than 151. Let me write that again. Greater than. Okay. So again, I'm going to do 1 minus. This is just going to save me a little bit of time when I'm calculating the area. Remember, probability is the same thing as area under the curve. So 1 minus normal CDF, I'm doing the yellow piece, 1 minus the yellow area. So lower limit would be 145, upper limit is 151. Mean, we said was 148. Standard deviation is right there. Remember, it said that key phrase sample mean. So that tells us to use our special formulas. So the standard deviation is 7 divided by square root of 50. All right, so second bars, go to normal CDF. Lower limit is 145. Upper limit is 151. Mean is 148. Standard deviation is 7 divided by square root of 50. All right, so that's what it should look like. And then just hit enter. Oh, perfect. Very big area here. So that's 0.9 to round, oops, sorry. If we round to 4 decimal places, that would be 9976. Very large area. So that would be almost 100%, right? That'd be like 99.76%. Okay. Now, what we just did today is we applied the central limit theorem to our probability problem. So basically, we just took the two special formulas we learned in section 7. Try this again. Those two special formulas that we learned in section 7.1 for the mean and the standard deviation of a sample and distribution of sample means, and we applied them to our probability problems that we already knew how to do. Tomorrow, we're going to do almost the exact same thing. The only difference is, instead of dealing with sample means in section 7.3, we'll be dealing with sample proportions, which will be like percentages. Like it'll be like, one example is a census shows that 9 out of every 10 people carry a cell phone. So 9 out of 10, that's a proportion. Retyped it and got your. Oh, okay. Good job. Okay, thanks for letting me know, Rebecca. All right, so we're going to be doing this same exact thing tomorrow. We're going to be using normal CDF again. We'll just have two new formulas for the mean and the standard deviation of a sampling distribution of sample proportions. So not terribly difficult, I don't think, because we've already done stuff like this before. The only stuff that is brand new would be these problems that says like differ by. I don't think we've done problems like that before, so that's new. But mostly just review. All right, I'm gonna flip you back over. All right, y'all, I can barely hold my eyes open. I'm so tired. So if you haven't already, please go in and complete the quiz for Unit 4. And, do the practice quiz if you haven't already. That'll give you 5 bonus points. And remember, I told you guys a while back, let's say that you did every practice quiz, and there's 6 quizzes. So that's 5 points apiece for 6 quizzes. That's 30 points. 30 bonus points altogether. So it may not seem like a lot doing like a 5-point bonus, but it really does add up if you do it for every quiz, or even if you do it for most of the quizzes. And it doesn't have to be perfect. All you have to do, so as you try to complete the practice quiz, then I'll give you the 5 bonus points. All right, so I'm going to sign off here for today, and I'm going to hopefully take a nap at some point today. And baby, you guys can take a nap too. You deserve it. All right, so I hope y'all have a great day, and I'll see you tomorrow.